Hi. The purpose of this video is to familiarize you guys with the requirements and expectations of the final project for this class. There is a handout that goes along with it, which you should probably read first before watching this video, because this video is going to just demonstrate how to do some of those things. We haven't quite learned everything that you need to complete the final successfully, so this video is to supplement some of those ideas. Okay, so the first thing you're going to be given in this project is a database, like this one you see on the screen. This database, or it's a data set of information. In this particular case, it's traffic tickets given in the state of Maryland in January 2016. So I got this off of website data.gov. You'll be given a data set yourself. This one will vary slightly from the one you'll get. So let's open it up and take a look, and we'll go through it and see what kind of things we can do with the data. So when we open it up, this is what we'll see. So within here, you want to acquaint yourself with all the different things, different columns first of all. So in here, the first thing we see is the date of the stop. So you see January 1st of 2016. If we scroll down, you can see it goes all the way through the month. Here we're at January 21st. You can see there's quite a bit of data points all the way down to January 31st. And there's 14,000 traffic tickets given in that time, apparently. So along with that is the time of the stop, the description for why they were pulled over, So, wow, here's an interesting one. Exceeding maximum speed, 106 miles per hour in a 55 mile per hour zone. So that's an example of a ticket that was given. If we scroll over, it shows the location of the stop, including the latitude and longitude, whether there was an accident involved in the ticket that was given. Was the person wearing seatbelts? Was there an injury that occurred or damage? Was it fatal? Did the person who got the ticket have a commercial license? Was this a truck driver of some sort, or was hazmat required? Was the vehicle a commercial vehicle? Was there alcohol involved? Was this done in a work zone? So yeah, as you can see, there's quite a bit of information in here. The year of the car, the make, the model, and the color, as well as the violation type and the charge. And this is all real information. The only thing I've made up just for this example is the age. The age was not in this data set, but I thought I'd add it, to make up some numbers just for fun to play with. The race, this is real data right here. The gender, that's all real. So you can see all sorts of stuff is in this data set. So what we want to do is analyze it. And what does that mean? We want to kind of look for some trends in the data. Some things that might give us insight into what's going on. What type of traffic tickets, where they are occurring, what kind of people are involved with it. And we want to use some of the math functions and formulas we've done in this class, as well as the spreadsheet examples to accomplish this. So before we get going any further, the first thing you want to do is probably split the screen. Okay, so I'm doing this in Microsoft Excel, but at the end of the video, I'll show you a few tips if you are doing this in Google Spreadsheets. Either one is fine. You can use either one. It'll look a little different if you do it in Google Spreadsheets, but the stuff we'll be doing can be done in either one. So up here, there is a tab called View, and it says Split. So we want to split the screen, and notice it splits the screen vertically and horizontally. So I'm going to remove the vertical split and drag the horizontal split up to the top. If you haven't seen this before, what this does is it allows you to see the category or the description at the top and zoom down and not lose sight of what it is you're looking at below. So I always put the split in there. Some of the things you might want to do is sort and filter this. Okay, so it's already sorted by date. So if you noticed, January 1st was at the top all the way down through the end of the month. But we might want to sort this by the time of the day. We might want to sort it by male and female, or latitude and longitude, or what year or car it was made, just to help, keep track of finding any trends. So what you do is you highlight or click on row 1, and you'll go to the Home tab and click on Sort and Filter, and you'll want to click on the Filter button. And what that does is it pops up these tabs for each of the categories. So the time of the stop, and it shows every possible time, so every possible time of the day. So this is literally 1, which means 12:01 in the morning, 12:02 in the morning. So you can filter this to only see certain times of the day. You can sort it from in size, and you can do this for any one of the categories. So that's something you want to keep in mind as you go through this. You might say, for instance, you want to only look at the males in this case. So that would be under gender. Right here, we'd click on that little drop-down menu, and then males. So we would remove unknown and female, and then we would press OK, and it would only show the males. So you might want to sort and filter this. Now, let's think about some of the things that we could come up with this data. The whole point of this final is to find some kind of trend or some kind of correlation in the data between, who knows? Maybe in this case it might be the time of the day versus the age of the person. It might be the type of citation versus male and female. All of those kind of things. We want to look into this. Who's wearing seatbelts, who's not. So one of the things you want to be able to do is use a histogram to accomplish this. Histogram is basically a type of graph that shows the amount of some instance in a different number of categories. So we could say every single day we want to see maybe how many traffic tickets were given on any day. So we would have 31 bars, and each bar would show how many traffic tickets were given on that day. So that would be a histogram. Now, histograms are not in Excel as a normal insert, table type. What we've done so far is use scatter plots or other types of graphs, but there are no histograms in here. So you have to actually do an add-in, one of these add-ins. So in order to make a histogram, what you want to do in Excel, unless you've already done this in the past some other time, is you want to make a histogram add-in. So you click on File, and then under here is add-ins. Options. So File, Options, and then add-ins down here. And you should have one called Analysis Toolpack. So now mine, I've already installed it, so it shows it as an active application, but yours will probably be down here under inactive applications. So you'll click on the Analysis Toolpack and then click on Go, and it will pop up this menu, Analysis Toolpack. We don't need the other ones, so just the first option, Analysis Toolpack, click it and press OK. And when you press OK, it will give you that add-in. Now you would think the add-in would appear under the add-ins tab, but it's not, of course. It's under something different, in this case under data, because the add-in is a data type of add-in. And so over here you should have this word now that says data analysis. This wasn't here a second ago, but it is now because it is what we added in. If you had trouble following this, just look up how to create a histogram in Excel, and you will find this. So I'm going to click on this word, add data analysis, in order to create the histogram we want. And there's all sorts of things you can create besides histograms. But in here, the one we're going to choose is the histogram. So click on that and press OK. And the first thing it's going to ask for is the input range. So what we're going to do now, I'm going to try this as an example. The person's age versus the number of citations. So there's, 11,000 tickets were given, and the age of the person varies, probably from 16 years old on up. So we want to know for 16-year-olds how many citations were given, and see if there's a correlation between their person's age and how many citations that age group gets. So under this input range right here, we're going to click on that button. When you click on the data analysis, it brings up this window, and it's going to ask for the input range. So this is the data that we're trying to graph, and we're trying to graph their ages. So I'm going to click on all of the ages. So I'm going to highlight all the ages all the way down. And since there's 16,000 of these, I'm going to just scroll down, and you can hold Shift N down, if you want to grab all of them, or just scroll all the way to the bottom. And that's going to be our input. Now the next thing it asks for is the bin range. The bin range. So we want to categorize these into ages, 16-year-olds, 17-year-olds, 18-year-olds, all the way up to 100-year-olds. And we want to see how many tickets were given for each one of those ages. So the bin range is each one of those categories, 16, 17, 18. So we don't have any bins right now. We need to create the bin. So over here, I'm going to cancel out of this and create the bins, which is usually the first thing you want to do. So picture bins as, as barrels, and we're going to fit all of the 16-year-old citations into the 16-year-old barrel, or bin they call it, and the 17-year-olds into the next one, and so on. So I got to create these bins. So up here I'm going to start with the number 14, 15, 16. Now there shouldn't be any 14-year-olds getting tickets, but who knows, maybe there might be a few. So I'm going to include those, and I'm going to scroll all the way down here until I get to maybe 100 or so, maybe 104-year-olds. I don't know if there are any 104-year-olds in the data, but it will capture them this way. So these are all the bins. Now these ages right here, say 26. Here the first person is 26 years old, so they're going to go into the 26-year-old bin. And it's going to, every one of these bins will start adding up every time one of these gets put into it. So let's go back to the Data tab and Data Analysis and click on Histogram. And once again, we're going to choose the input range. It looks like it's already selected from before, but I'll do it again anyway. And the bin range. The bin range will be all of these numbers we just created. So anytime you create a histogram, you want to create bins, and that's part of it. Alright, press OK. So what it does is it creates all of these bins. And so it looks right here, 14-year-olds, there are 0 citations given, 15-year-olds 0. So it looks like it starts at age 16. So I'm going to delete these two because they were not necessary. And now it put this in sheet 2 over here. So I'm in a new sheet. I'm not in the same traffic violation sheet as before. I'm going to delete these two by right-clicking on the row and pressing delete. I'm going to scroll down and look and see if there's any more down here. Okay, it looks like it stops around age 91. So I'm going to highlight everything past that because we're not going to need to graph that. Okay, so here is each bin and how many citations were put in each one of those bins. So 16-year-olds, there was 509 citations given to 16-year-olds. Let's go ahead and graph this. So I'm going to highlight all the numbers. And I'm going to go to Insert. Let's do a bar graph on this one. Insert column chart. Oops. I'm going to do a scatter plot for this one. Insert scatter plot. So what we see here is a scatter plot of the number of people, number of citations versus the age. And you can see these 20-year-olds are getting the most number of tickets, and as age goes on, less and less tickets are given to this age group. So really this is a histogram, except it's also just a normal scatter plot, because the data put in the scatter plot was based off of the histogram we created. If we wanted to, we could change this chart type here, instead of being a scatter plot, to be by clicking on the Design tab and change chart type. We could change it to one of these right here, one of these bar charts. So we'll try that. So it shows as time goes on how many tickets they were getting. Now the neat thing about this one is it looks like there actually is a correlation involved. It's going down. So what we want to do is, since we found something interesting here, we want to give it a trend line and see what the equation is to model the number of tickets per age group. So what you'll do is you'll click on the data and then right click, add trend line. Now over here, we've seen this before. You could add linear trend lines or polynomial. To keep it simple now, let's just add a linear trend line. And I want to display the equation on the chart. Okay. So right here, this is the equation modeling the number of tickets per age. So X would be the age, and Y would be the number of tickets. So for instance, how many tickets do 60-year-olds get typically in the month of January? You'd plug in the number 60 into X, and this formula would tell you the output would be the number of tickets, which should be, the answer should be roughly around 150 or so, based off of the data. Now this line is to model it, but it's not a perfect representation. You can see there's some error involved in here. You know, 26-year-olds happen to get a lot of tickets right up here, but if you use the trend line, it would say that the theoretical number of tickets would be somewhere around 350 if we used the analysis, this equation here. Okay, now what you're going to be doing with this graph is, once you find some kind of correlation like this, you're going to make note of it, and you're going to add it to your paper in the final product. What you'll want to do is not only make graphs and charts like this one, but you want to describe what you found. This means something to somebody. What this is saying is that as age goes up, tickets go down. Now, does that mean that's because there's less drivers at the older ages, or is it because they're safer drivers at older ages? You can't tell from this graph whether that's the case or not, but there's definitely a correlation between age and the number of tickets, which is what you found. The other thing that you can see from this graph, if I make this a little bit bigger, these words for this equation here, is that there's a slope involved with the graph. Now, you want to describe this in your paper as well. What does that number mean? Negative 5.777. What that is for every year you get older, there's 5.777 tickets less that's given out to that age group. So you can imagine 10 years down the road, there's 57 less tickets because for every year it went down 5.7 tickets. Now, what we also have right here is the y-intercept, 414. That's the starting point. At age 16, the data shows that they expect to give 414 tickets. So what's neat about this is if you're the city, you can make guesses in future years based off of the age and some of these violations that the kids, that the people have. All right. Now, when you're doing this, you'll want to make it a little prettier, changing the chart type. You might say it's the histogram of ages versus number of citations. You could add, since it's your final product, you'll want to add some stuff that you learned in previous lessons on formatting the table. So when you click on the chart and click on design, under the add chart elements, you can add all sorts of stuff. Titles for each axis, a legend. So go ahead and play with these to get it to be exactly what you want. I'll show you one of them. The axis titles. If I add an axis title to the horizontal, right down here, you can change these words to say age groups. And then I could add a vertical axis title. And over here I would change this to say number of citations. And you could do a lot more with this to make it look nicer. Notice that this is in sheet 2. So I'll want to rename that sheet, and I'm going to arrange these as I go. So sheet 2, I'm going to rename it. So you right click and rename whatever you want. Maybe ages versus number of citations. It'll be a lot easier to grade if they're organized this way and titled. All right, so that's histograms. We're going to do a few more just to give you some more examples. Another thing I'm interested in as you're looking at the data, I wonder what relationship there is between the time of the day and the number of citations given during that time. Okay? So if we look over here, it looks like they're all rounded to the nearest minute. And so there's 24 hours times 60 minutes and an hour. That's quite a few bins worth of information. If I did the math real quick, 60 times 24, there's 1,440 possible minutes that a ticket could be given in a day. And if we did a histogram with 1,440 bins, you couldn't really do much with that. What I'd like to do is create a histogram that shows maybe only 100 bins worth of information. So I'll show you how to do that. Basically every 15 minutes, how many tickets are given during a 15-minute span for every 15-minute portion of the day. So the first thing I'm going to do is I'm going to round these numbers right here. So I'm going to insert a new column and call it time of stop rounded. And what I'm going to put in here is I'm going to round this time, and I'm going to use the ceiling function. That's a good one for this. The ceiling. It basically rounds it, but it always rounds it up. The ceiling of this number to the nearest 0.01. If you recall, times are, if you were to convert these times into a number, it's always the portion of the day that it's rounded to. So what I'm saying is, if I convert this time into a number, 0.577, that means, you know, you're a little bit more than halfway through a day. You're 0.577 worth of a day, which is about 1 o'clock in the afternoon. And that's what this time is referring to. So when you round this, we're rounding it to the nearest point. We're rounding it to the nearest 0.01. So the nearest, so right here, the answer would be 0.58. So 1/100th of a day is about 15 minutes, right? Okay. So I'm going to take this and drag it down. So all of these numbers will be rounded to the nearest 100th of a day. So 105 rounds to 112, and so on. So now we'll have 100 bins. So we got to create these bins. So over here on the right, I'm going to add next to the last set of bins, I'm going to add some more numbers. So I'm going to add the bins 0.01, 0.02, 0.03, and so on down to 100. Okay, so in my histogram, I'm going to separate my data into 100 bins, each at these 15-minute increments. Now I should be ready to create the histogram. Let me switch this back to my time. Okay. So I'm going to insert, data analysis, histogram, and my input range will be the time of the stop. So I'm going to highlight all of these all the way down to the end. And again, to go all the way down to the end, you hold shift down, and then you press, while you're holding shift, you press the end key and the down arrow, and it'll grab all of it. Next, the bin range. The bin range is what we just created over here, the 100 points. Here's the 100. So it's going to take this data and put it into 100 bins. So if we look here, we see some interesting information. I could actually convert these numbers back into times, so it's a little easier to understand. I'm going to convert this into, click on the Home tab, change it back into a time, and we can see it's about 15-minute increments, right? So that's where these dates and numbers correlate. So 12 o'clock in the morning, there were about 252 citations versus 350 in the morning, there was only 54. And down here, 5 o'clock in the morning looks like the best time to drive because there's only 13 tickets given out in the entire month around 5:30 in the morning in Maryland. So we want to graph these. So again, same thing as before. We'll highlight all the data and go to Insert. And again, I'll try the two-dimensional column histogram. And here is what it looks like. To make it bigger so you can see what I'm talking about, here's the time of the day along the bottom and the number of tickets given within that 15-minute period. Okay, so if you see this, there's definitely a relationship between the time of the day and the number of tickets given. At night, there's definitely something to see here, and this would be something you'd want to put in part of your paper, is explaining that there's this relationship right here. Okay, and so what does that mean? We don't know exactly what the cause is, but we know the effect is that the best time to drive and avoid getting tickets would be 4 in the morning. Now, is that because there's less people driving, or is there less law enforcement on the streets? Who knows? We can add a trend line to this. Okay, now this does not look like a linear trend line at all, right? We couldn't fit just a straight line across here because it's all over the place. So we're going to try a different trend line. So you right click on the data, add trend line, and this line tries to approximate the information, but it's not even close. So don't use a linear. Polynomials are pretty good. And what's nice about this is the equation that we get from it will mean something, but we don't have to figure out what the equation is ourselves because the computer does. So this trend line still does not lie on top of the data very well. So what I'm going to do is increase the order. And let me show you what that does. I'm going to display the equation on the chart and make it bigger so you can see what this equation is. Make it a little bit bigger. Okay. So this is a polynomial of order 2. And the 2 comes from this square, this squared term. That's why they call it a second order polynomial, because the biggest term is a squared term. If I make it a third order, okay, here is a cubed factor, a 3, so that's what the third order is. Notice this still doesn't look good. I'm going to add a fourth order. This equation now models roughly what the data is showing. It's getting a little bit closer. So a fourth order polynomial is close, but let's keep going. Let's add another layer, another order to this. Let's add a fifth order. And now you can see the difference between the fourth order and a fifth order. It's kind of mimicking the data a little bit closer. And then a sixth order. A sixth order shows this. So this line right here simulates the data, meaning we can guess what the trend is on any particular time by plugging that into this ugly equation up here. This equation, this is a very complicated equation, but all you care about is knowing how to use it. And so what that means is this x value is the input into the equation. And so if you look at your x-axis, the x-axis is time. So if you plug any particular time into here, into all of these x values, you'll get out an output of y. And the y is the y-axis, which is the number of citations. So for instance, if we want to figure out approximately how many tickets are given at noon, okay, we can see that there should be 159 tickets given at noon. Now noon is the number 0.5, right? Because noon is half of a day. So if I use 0.5 and plug it into this equation up here, 0.5 would yield a number of that 159. So that's what this equation does. So this is the kind of thing you can add to your final Word document showing, explaining that this equation models the time of the day versus the number of tickets given, and that there is a relationship, and that the time of the day does help determine how many tickets are going to be given. Now you'll notice in this graph here there was 100 different bins. If we wanted to, we could have narrowed this down to only 24 bins, right? 24 bins, because one bin for each hour of the day. So let's do that one real quick. And again, I'm not going to go through this again, but you'll want, anytime you do a new chart, you'll want to you know, make it look a little nicer with changing the titles and adding some stuff to it, like the units or the titles or the legend, the axes. Also, you want to rename the sheet. So right here, this is in sheet 3. I'm going to drag it over to be in front and rename it number of citations per 15 minute per 15 minutes. Okay. So basically I want to recreate the same graph except with only 24 bins. So if we go back here, we've created 100 bins. Let's only do 24 bins. So the way you'll do that is we need to do 1 divided by 24, right? That would be 1/24th. And then we want equals 2 divided by 24. And then we want 3 divided by 24. And so these bins are going to be 24ths of a day. 24ths of a day. Now if I try to drag this down, it won't work. It won't work. It doesn't find the sequence correctly. So the better way to do this would just to type in 1, 2, 3, 4, and drag that down. And I think I'll start at 0 and go to 23 instead. 0 representing midnight. So this is going to equal 0 divided by 24. Right? This cell divided by 24. And the same thing for the next cell, right? 1 divided by 24. And I drag it down. 2 divided by 24, 3 divided by 24, 4 divided by 24. So here's my bins, and I've created 24 bins. So let's do that histogram again with these bins in mind instead. So we're going to go to insert, data analysis, histogram. I'm going to pick the time of the stop, which already is selected, and the bin number that we just created. Now you might have noticed right here that I selected the time of the stop rather than the time of the stop rounded. So you don't really need to round it to the nearest 15 minutes or 24ths of a day. It will force it to be in whatever bin is closest. So that was kind of extra, that column C we created earlier. That's not necessary. All right, so here's our bins. I'm going to graph this. And it should look the same, except with only 24 bins. So we can see 11 o'clock at night is definitely, around 11 or 12 at night is when the most tickets are being given. Now remember, when you're doing this, the point of doing this is to find some kind of relationship. And this is what you're going to report on in your paper, what you found. Next, we're going to talk about pivot tables and pivot charts. We haven't done this yet, but a pivot chart is even more useful than a histogram, and you'll probably create most of the rest of your graphs using a pivot chart. So a pivot chart is one of those things that's easier to show you it than it is to explain it. So let me show you it, and then you'll grasp it very quickly. I'm going to delete this sheet. I don't need it. Okay, so we're going to create a pivot chart. So what you're going to do first is you want to highlight all of the data that you have, everything in this data set, including the titles at the top. Okay, so I've highlighted it all, including the column titles, and I'm going to go to Insert Pivot Table. Actually, Insert Pivot Chart is what we want to do. And it's saying, okay, well, what data do you want to use for this pivot chart? And I've already selected it, so it's already there. So I'm just going to press OK. And once again, down here at the bottom, it says Sheet 5. And this is, I'm going to move this over to the end. And this is where my chart, my pivot chart is going to be. What's cool about a pivot chart is, well, it creates a pivot table at the same time, which you don't know what that is yet either, but it does both. If you do a pivot table, you know, if you insert a pivot table, it doesn't give you the chart. But if you do a pivot chart, it gives you both, which is nice. So, what is this pivot chart? It's kind of a way of graphing things live by their categories rather than trying to do them manually by hand like we've been doing. So, for instance, I'm curious about knowing in the month of January how many citations were given per day. So down here in the bottom corner there's 4 areas, and I'll show you what they do by just making a pivot chart. So what I'm going to do is plug in the date of the stop. I'm going to drag it. So you hold it down and drag it into the axis category. Okay, so it's almost like it made a bunch of bins, like the histogram. And then I'm also going to drag it, the date of the stop, into the values. And so what it just did is it made a graph, a pivot graph, automatically. And it's really cool because it's a faster way of creating charts. So for instance, what it just did is it shows January 1st, there were 693 citations given. January 2nd, 569. And so it looks like there's a few days where hardly any citations were given. And this is real data. So I bet you if we looked up January 24th, 2016, it would probably be a weekend. You know, and that might be something you want to put in your paper, is that you noticed that during the weekends less tickets were given out, and so that might be useful to people to know that kind of thing. Or maybe during weekends more tickets were given out. It just depends. So you'd look into that. Okay, now the way this pivot chart works is it created, when I drag that date of stop down, that's basically your y, your x-axis type of information. And what do you want to show on that chart is the values. And we counted the number of times that date showed up. So quite a bit like a histogram. What's neat about this is we could also make a trend line on this chart. So once again, you right click, add trend line, and again the linear trend line is not a good fit, so I'm going to add a polynomial of order . You'll notice it only goes up to order 6, which is a pretty complicated equation, but a polynomial of order 4 is pretty good as well. Always display the equation on the chart. And so that might be your equation simulating what's going on. And so it's quite interesting too that at the end of the month there was less tickets given out. Maybe they met their quota for the month and so there wasn't as big of a need. Maybe officers were busy doing other things. Okay, so So you'd want to, again, kind of make this chart look a little prettier, changing the title to mean something. Notice I didn't have to add anything into the other categories for filters or the legend. We're going to do some more pivot charts to give you a good idea of how to do this. Okay, so typically you'd want to create another, if this information is useful to you and it means something, leave it and you'll write about it in your paper, and then create a new pivot chart. So pivot charts are pretty much the same. You do it the same way every time. You highlight all the data. You click on the pivot chart button under the insert tab. And it's going to pop up with this. I'm going to just reuse this one I started already. Okay, oh, and I skipped that. What I just did was, if you want to change your chart around, you just drag off the thing that was on there. So I want to do one. I'm curious about males versus females. Are they getting any more tickets, any less tickets? We know there's the same number of male travelers as there are female, or male drivers as there are female. So under this pivot chart field, we're going to look for gender and move it under the axis category. And then we want to count the number of genders as well. So I'm going to just drag that under the values category. And there we go. Quite interesting. We just discovered something else that's new. The females versus the males. Right here, it gave a table of the data that's in the chart. Males got twice as many tickets as females. And this is real data. I didn't make any of this stuff up. So this is, all real numbers here. That's quite interesting. That's having to do with insurance companies, and the cost associated with your insurance is a big reason why it's more expensive for males. They're getting more tickets. Now, what about contributing to an accident? This is interesting. I want to know if I add something to this chart, this label right here, contributed to an accident. I'm going to move that into the categories as well. Okay, and so what we see here now is we put two things on this graph, males and females, and whether their ticket contributed to an accident. So what I notice is that the males, again, were still given twice as many tickets, and the males had twice as many accidents associated with the number of tickets that you can see in the numbers right here. Males, yes, there was an accident. Females, yes, there was an accident. But what's interesting is the ratio is about the same. For every 4,600 tickets given to a female, 104 of them had to do with an accident. And for males, 223 tickets were given, and 9,500 tickets were given, and 223 had to do with an accident. So what this tells me is that males are getting tickets at twice the rate, but their rate of accidents are the same as females. So you can analyze, what does that actually mean? Does that mean that males are getting more tickets than they need to be because it's not like they're having more accidents as a result? Or, you can kind of chime in on what you think that actually means when you write your paper. Another thing that I think would be interesting is who wears seatbelts, right? Males and females, were the seatbelts being worn? So I might add this category right here, wearing seatbelts. I'm going to drag that down. And notice the wearing seatbelts, I put that into the columns, into this section. So it's kind of like the y-axis information. It can get a little ugly if you add too much to this, so I'm going to get rid of the contributed to an accident. And I can add the wearing seatbelts to the rows, or I can add it to the columns. It's just going to appear a little differently. So let's look. The orange represents yes, they were wearing a seatbelt, and blue represents no, they weren't. And so once again, you can do some math here if you wanted to figure out the percentage of females who got tickets versus the number of tickets that were given. So let's see. Females, I'm going to say equals 781 of them were not wearing a seatbelt out of 4744. So 16% of the tickets given to females were not wearing a seatbelt. Let's look at the males. Equals, oops, don't click on that. Just type in the number. It gets a little ugly if you click on the cell. 1604 divided by 9818. And if you look, those numbers are nearly identical, which, I mean, it doesn't sound important, but it is important. It means males and females essentially wear their seatbelts at the same rate. So that does mean something, even though their numbers aren't different. Now, part of the final is to create formulas like the one we just did using some of these, simple functions like division. Anytime you do this, please highlight the cells and make them yellow. It'll be a lot easier to see what you've done to the data if you make it obvious like this. And you the grader can check and see what was done and spot it a lot easier. Now you notice the little table over here went away. To get that little table to come back, you click on the graph, or you can click on the pivot table as well. A couple more. I'm curious also about, there are headlight tickets that are given. I'm going to remove these categories and start over. Alright, so if we come up here, there's the description of the type of tickets that are given. So I'm going to take this description and drag it down. Into the axis. And right here is all of the various types of tickets that were given. Now, unfortunately, there's, 873 types of tickets, so it's not like they've broken it down into the top 10 or 10 types. So I'm going to just look at the headlight tickets that are given. Okay, so I want to look at just headlight tickets. So you can either click on this arrow and search for headlight tickets in here, or you can take the description and drag it into the filters section and choose just the headlights. So I'm going to look for headlights. Headlights. Oops, click on it, press OK. So the only thing that will show up in this table is the headlights. And what I'd like to do is look at the time of the stop. And I'm going to count the let me start this over. Sorry. I'm going to move the description. Instead of filtering it in here, what you can do, it'll be a little easier if we move it as well into the values. Okay. One second. So so what you see here is I'm counting. I moved the description into the values area, and so it's going to count the number of times a headlight ticket was given, and it's only doing headlights because I only chose headlights in my filters. And then I use time of stops as my x-axis, which I put down here. Now what you'll see is, what's interesting about this is people were given, you would expect no one to have gotten a ticket for headlights in the middle of the day. So it's weird that some people are getting tickets for headlights in the middle of the day. But what you do notice is there is a correlation between the number of headlight tickets given and the time of the day. It goes way up at night. Okay, and then as you would expect, as the night goes down, and day starts, there's less tickets given. But it is still interesting that people are given tickets during the day. Maybe some daylight or daytime running lights were on and one of the headlights was out. I don't know. Okay, this video is long enough. I want to just talk about a couple last things here. You are given the freedom in this assignment to come up with anything you want in terms of what you think would be interesting and a possible trend. So if it was me, I'd be very curious about maybe the alcohol, if there's alcohol involved versus the age, or perhaps the race versus the number of tickets that were given, or the type of car versus the gender, all sorts of interesting things that you can look at and graph and find out. One thing that you don't want to forget is that you can also just do normal scatter plots with all of this data. So suppose you want to graph the time of the stop versus maybe you want to graph the person's age versus the year of the car that they were caught. Maybe you're curious about not even traffic tickets, but what kind of cars are people driving at certain ages. Maybe you'll find some interesting relationship there. So just like a normal graph, we would highlight the year of the car. So I'm going to highlight all these. And then I'm going to graph it versus their age. So I'm going to insert a normal scatter plot. And so in this scatter plot, notice it put it right on top of the data. We don't want it there. We want it to be in its own tab. So we're going to right click and move chart to a new sheet. And I'm going to call it year of car versus age. Now we haven't added the age yet. To add the age, you right click on the chart, select data, edit, and there's no X values yet. So I'm going to select on the ages of the people. Wait a minute, it messed it up. Let me try this again. Okay. And press OK. And so what it does here is it shows the people and their ages and how many, and the year of the car that they got the traffic ticket in. So you can see age, 15-year-olds, they're driving newer cars all the way down to older cars. And the older generations, older people are driving slightly newer cars. So there's not a whole lot we notice in this data. We see the oldest car that was given a ticket was 1970. Pretty much everything else is 1982, 1984 and old and newer. So that might be interesting, kind of tell what kind of cars are out there, what kind of cars are getting tickets. It also might say that people who drive classic cars are not getting tickets for whatever reason. Or maybe that this Maryland doesn't, has really strict laws on those older cars. So some interesting things here. Okay. lastly, well, not lastly, almost lastly, there part of the assignment is to also use some of the normal functions that you would in Excel to show various types of information. So, for instance, we want to maybe find the average age of the people getting tickets. Okay, so you go down to the end of the age category and type in equals average of all of those in that column. So 8 from cell 2 to cell 14, 568. I'm going to find the average age. So it looks like the average age is 39. Okay. Anytime, again, that you do this, that you make a change like this, it's going to be hard to, whoever grades this, for the instructor to see this because there's so much data. So please make it yellow so it's clear that you use that function. Maybe the min and max as well, right? You might type in minimum of all of those. So the minimum age was 16, which we already knew that, and the maximum age was 90 something, I believe. 91. So I'll make those yellow. And you might type in something right here just so the instructor knows what you're saying. Average age, minimum age, maximum age. Okay, we could also do maybe a formula with the slope of the ages. So I could type in equals slope of all of the ages So what I'm doing with this slope here is I'm graphing the ages, or I'm finding the slope of the ages versus the time they got a ticket. So the time they got a ticket would be over here. So from B2 to B14, 568, those are all the times. And these are all the ages. And so I get a slope of time versus age that the tickets were given. And you get a slope of negative 0.26. So if this is that equation y equals mx plus b, this would be the m value. Now this probably doesn't really mean anything to you, but it would if you were to graph this on a regular chart, and you would see how this slope, what this slope actually means. Same with the intercept. I'm going to take this and copy it and say, oops, and paste it down here and say the intercept rather than the slope. Intercept is 39. So again, if this was the equation y equals mx plus b, this would be the b. This is the y-intercept. Intercept of time versus age. Okay. So there's a way to use a few of the functions. There's other functions you could do, like transposing data. You know, say you want to transpose the data, which means instead of being in columns and rows, put it in rows and columns. So what I mean is, say for instance, this data you want to transpose. So you would pretty easily, you just copy this, click on the place you want to transpose it. You would right click and paste special, and there's an option for transpose, and you press OK, and you can see white 17, white 47, white 28. That's exactly what shows up here, except it's kind of flipped 90 degrees. White 17, white 47, white 28. So this may not mean much to you now or be very useful, but it could become very useful later in the future when you're dealing with data and you need to kind of switch things around to make graphs look better, or to, you know, put the data into something else that needs it to be facing the opposite direction. Okay, and again, since we transposed it and did something with it, we would make it yellow so we could see that something was done. One other thing we could do is the if statements, which is another requirement in this. So a lot of things in here could be found using these if statements, a lot of trends or relationships between these things. So you'll definitely want to do some if statements in your analysis. If statements. So what am I talking about? So for instance, something I might be curious about would be if the driver is a male, okay, so if the gender is a male equals male, and, okay, comma, and they are older, and the driver is over age 60, for instance. Okay. So we want to know both of these. If they're a male and they're over 60, so we have to use the AND function. And so we're going to AND these together. So this AND function says if they are a male and greater than 60, then say let's make this true. Otherwise, let's make it false. So we've done these if functions in the past. So here's just another example of this. So let's see if we can get any of these to show up. Here's a true value right here. So let's look at this one. This person is a male and they're greater than 60. So it shows up as true. So for instance, if you're just trying to narrow this down to a specific subset of people to kind of find what, you know, what's going on with maybe their race, maybe we look at all the white people or the black people or the Hispanics, and based off of that we look at what kind of description or the time of day, we can make an if statement to see if there's any correlation between these things. So we might say if the person is Hispanic and the time they got the ticket is greater than 0.9, then that, and then we could do the same thing for if they are white and the time they got a ticket is greater than 0.9. We could count those and see, you know, if there's any relationship between the race and the time they got a ticket. So what you could do, and this could have been done at the beginning of the video, was to make a bunch of these if statements, and you can use these, you know, and put these in all of your graphs. You know, you could have a bunch more categories in your data set of if statements and use them as part of your charts. So that's another thing. So I believe there's a requirement in the final to do some if statements. Now the last thing I want to mention is how to do this using Google spreadsheets rather than Excel. Excel is a little easier to work with, but if you are only able to use Google spreadsheets, I need to show you how to insert the histograms and the pivot charts. Okay, so let me bring that up. So if you go to your Google Drive, you'll click on a new Google Sheet. Okay, and you'll have to, for the histogram, you're going to have to click on add-ons. And under here, you're going to go to get add-ons. I've already done the toolpack add-on I need for a histogram, but for you, that probably won't be there. So you click on get add-ons. And the one that you want, sometimes it shows up right at the beginning, but since I've already put it on mine, it's hard to see. Yeah, there it is. It's checked for me because I've already done it. Yeah, this Excel minor analysis toolpack. So you'll click on that one and you'll add it. You'll have a button to add it. Okay? And then it should show up in your add-ons. And then you can create your histogram very much the same as the beginning of this video. So click on Start, and it'll ask you the same kind of stuff as before. It'll ask you, there it is, what kind of analysis you want to run. We're just doing histograms. And it'll say the input range. Okay, we don't have any data in this spreadsheet, but the input range would be all of the values and then all of the bins that you're using. Like we did with the ages, 16, 17, 18, you'd have to write all of the bins that you want to sort these into right in there. So besides that, that's the only difference in the spreadsheet version. The other last thing is the pivot table. That's going to be under data pivot table. So it's in a different spot than in Excel. So you click on data pivot table, and it's after that it's going to be pretty much the same. You would highlight all of the rows. Let me put some fake data in here to give us something. So I'm just going to put this data in. So the input, oops, let me start that over. Data, pivot table. What data do I want? I want all this data here. And it's going to look very similar to the other one where these 4 categories were the same as these 4 categories down here. Okay, so the filters, the values, the rows and the columns. So let's say for the rows we want to add the date of the stop, and for the values we want to add the gender. Oh, I don't have gender on here. I didn't. Maybe whether they were wearing a seatbelt. And then we could add the time of the stop as well. Okay. Now the difference with using a Google Spreadsheets is it creates the table for you, but you would have to graph this manually. So you'd have to come in here and highlight the data and then insert a chart. And so there's your chart. So you'd have to do that secondly after the fact. Now if you need a little bit more help with how to create these histograms or pivot tables within Google Spreadsheets, here's a couple YouTube videos that work that I found to create pivot tables and charts in Google Sheets, or this one, how to use pivot tables. Those are pretty good, and that should get you going. So other than that, I I just wanted to remind you guys about the whole point of this this experience. Really, is with this final project, you want to find trends, find correlations, find relationships between the data, and find something interesting and report on it. Put that in your paper. Hopefully, some of the math functions that and the charting elements that we've learned in this class will help you out. There's a lot of things I didn't mention in this video that you could use with matrices or other types of functions that we've talked about throughout the class. So feel free to use any of that kind of stuff to accomplish this task. And good luck. Hopefully this will help you.